Good day. Welcome to my new math tutorial video. This day we're going to talk about the law of sines. To solve oblique triangles using the law of sines. The triangle is determined by a tree of its 6 parts, angle, and side, as long as at least one these 3 parts is a side. So we have cases 1, 2, 3, and 4. We're going to find and we're going to recognize which of these cases are solved by using the law of sines. So the case 1, if we have triangle, the value that was given, let's say one side and two angles, or side angle, then that is solved by using the law of sines. And then case number 2, two sides and the angle opposite one of those sides, or side angle, then that is solved by using the law of sines. And well, cases number 3 and 4, the two sides and the included angle, or side angle side. We have triangle given the value side angle side, and then we have 3 sides, or side, then that are solved by using the law of cosines. So in this video we're going to focus on the law of sines. So the law of sines: the lengths of the sides of any triangle are proportional to the sine of the opposite angles. The angles of a triangle are labeled A, B, and C, and the lengths of the corresponding opposite sides are labeled A, B, and C, just like the figure below. We labeled it ABC, and then the angle at the opposite side labeled as small ABC, small letter. The law of sines: in a triangle, we have, this is the formula: sine A over A equals sine B over B equals sine C over C, or we can write it sine A over sine A equals B over sine B and equals C over sine C. So it depends on you. So we're going to use that formula. So the proof is by the formula of the area of triangle ABC is 1/2 times AB times sine C. The area of this triangle is also 1/2. The area of triangle we're using, so 1/2 times AC times sine B, and 1/2 BC times sine A. Thus, 1/2 BC times BC sine A equals 1/2 AC sine B equals 1/2 AB sine C. So multiplying by 2 over ABC gives the law of sines. So that is the proof. So we have examples. Example number 1. We are going to solving a triangle. We have the figure of the triangle. Example number 1, solving a triangle. We have triangle ABC and the opposite sides ABC. So the opposite of angle B, the opposite side of angle B is unknown, and the opposite sides of angle C is unknown, which is 80.4, and the angle A, opposite side of angle A, is unknown. So we have angle A and angle C. The value of angle A and C are known. So we have angle A 20 degrees and angle C 25 degrees. Well, angle B is known. First, we are going to find or solve for angle B. So we have in a triangle that is equal to 180 degrees. So 180 degrees minus we have 20 degrees, angle A plus angle C 25 degrees. The total is 135 degrees. So the angle B is equal to 135 degrees. Since side C is known, to find side A, we use the relation. The relation which is sine A sine A over A equals sine C over C, or A over sine A equals sine C over sine C. So if we're going to multiply or cross multiply, so the value of side C 80.4 times sine 20 degrees over sine 25 degrees. By using scientific calculator, we could find the value of side A. So we get approximately 65.1. So the side A is equal to approximately 65.1. We using the law of sines. So similarly, to find side B, we use this formula. B over sine B equals C over sine C. We're going to put the value of sine C and sine C and sine B. Since we already know the value of angle B, which is 135 degrees, so to find side B, B over 1 sine 135 degrees 135 equals 80.4 over sine C, which is 25 degrees. So B equals 80.4 times sine 135 degrees over sine 25. So we get approximately 134.5. So that is the side B. So angle B is 135 degrees. Then side A is approximately 65.1, and then side B is approximately 134.5. So that's it. So we have example number 2. Solve triangle ABC where angle A equals 45 degrees and side A equals 7 square root of 2 and our side B equals 7. So that is solved by using the law of sine. We first sketch the triangle with the information. So our sketch is necessarily tentative since we don't know yet the other angles. However, we can see now the possibilities. So as we sketch, so the triangle ABC, so we have angle A is given 45 degrees, and then angle A is given also, which is 7 square root of 2, and then the angle B and C, the angles B and C are unknown, but the opposite side of angle B is known, which is 7. So that is how we sketch the triangle ABC, where angle A equals 45 degrees, side A 7 square root of 2, and B equals 7. Since angle B is unknown in the triangle, so we're going to recognize angle B. So we're going to solve that. So by using the law of sines. This is how we're going to find out angle B. So we're using the law of sines. Sine A over A equals sine B over B. Since our angle A is given, so we put the value of angle A and side B in this formula. So sine B equals side B times sine A over side A. So the value of B is 7, as we sketched lately. Then the sine A is 45 degrees, and then over side A, which is 7 over 7 square root of 2. So we divide 7 by 7 over 7 square root of 2. Then that is equal to 1 square root of 2, because 7 over 7 square root of 2 is equal to 1 over square root of 2. So since we have sine 45 degrees, so we're going to get the value of sine 45 degrees from trigonometric values table, which is square root of 2 over 2. Since 45 degrees as our reference angle, we can easy to get the value, the trigonometric value. So that is square root of 2 over 2. So we're going to solve now the angle B, or for sine B, which is we're going to multiply 1/2 times 1 square root of 2 times square root of 2 over 2. That is 1/2. That is 1/2. Which angles B have sine B equals 1/2? From the preceding section, we recognize that there are two such angles smaller than 180 degrees. So they are 30 degrees and 150 degrees. Which of these angles is compatible with what we know about triangle ABC? So since we have sine angle A equals 45 degrees, we cannot have 100. We cannot have 150 degrees. We cannot have angle B equals 150 degrees, because 45 degrees plus 150 degrees is greater than 180 degrees. So that is not applicable. So angle B equals 30 degrees. So 30 degrees is our angle B, and the remaining angle is angle C. So 30 degrees, angle C is equals 100. To find the angle C, 180 minus 30 degrees plus 45 degrees. So first, 30 degrees plus 45 degrees is equal to 75 degrees. 180 minus 75 degrees, that would be 105 degrees. So that is our angle C, 105 degrees. And now to find side C, we're going to use the law of sines. So we have sine B over B equals sine C over C. Since we already know the value of sine B and sine C, angle B and angle C, and we have also side B. So to find side C, we're going to cross multiply. So first, to find C, we have side B times sine C over sine B. So we put the value of side B and angle C and B. So we have 7 times sine 105 degrees over angle B, sine 30 degrees. We solve for side C by using scientific calculator. So first, we're going to multiply 7 by sine 105 degrees, and then divide it by the result divided by 1/2. So 1/2 is from our trigonometric value table of sine B, sine 30 degrees, so which is 1/2. So the total is, by using scientific calculator, we get side C equals approximately 13.5. That's it. So now we already know the values of angle ABC. So the value of angle C is 105 degrees, and the value of angle B is 30 degrees. So 45 degrees plus 105 degrees plus 30 degrees, that is total of 180 degrees. In a triangle, always remember that that is total of 180 degrees. So the unknown value of side C is already solved, so which is approximately 13.5.